So what causes refraction? Okay, we know that light travels at different speed in different optical media. For example, in air, your light travels at 3.0 times 10 to the power 8 meters per second, which we learned previously, very similar to the speed in vacuum. Then in glass, the speed of light is 2.0 times 10 to the power 8 meters per second. So at the boundary of the two media such as air and glass, when the light enters from the air to the glass, you find that there's a change in the speed of light. The speed of light actually decreases. And this change in speed will cause the path of the light to bend and result in a refraction. So in this case, when the speed decreases, your path of light actually bends towards the normal. Okay, what causes refraction? We know that light travels the fastest in vacuum at 3.0 times 10 to the power 8 meters per second. Okay, and in air, the speed is similar to the one in vacuum. And light will actually slow down in an optically denser medium, example, your glass or water. So again, let us look at the example of the ray of light that strikes and refract at the surface of the air and glass. Okay, so as the incident ray enters from air into glass, see how it bends at the air and glass boundary. Okay, from here, the air, which is an optically less dense medium, entering the glass, which is optically denser medium, the refracted ray bends towards the normal. Originally, the ray is supposed to travel this direction. Now it bends towards the normal. Now we also have two laws of refraction similar to your reflection. So the first law of refraction states that the incident ray, refracted ray, and the normal at the point of incidence all lie in the same plane. Very similar to your reflection, except that reflected ray has been changed to refracted ray. Now the second law of refraction similarly gives the relationship between the angle of incidence and angle of refraction, but we are not going to cover it now. It will only be covered in IP3 physics. Okay, so for now you only need to learn the first law of refraction. In this slide, we are going to look at the refraction of light in different media. Okay, when light travels from air into glass, we know that the speed of light decreases because glass is an optically denser medium than air, and the light ray will bend towards the normal. Similarly, when light travels from air into water, the speed of light decreases and the light ray will bend towards the normal as well. However, glass is optically more dense than water. So when the light ray enters from air into glass, the speed decreases much more than in water. As such, the light ray will also bend more towards the normal compared to when in water. So you find that this RG in glass here, this angle here, is actually much smaller than RW because the light ray bends more towards the normal. Okay, now we come to the second learning outcome where you need to define the term refractive index. So it's given there, refractive index N of a medium is defined as the ratio of the speed of light in vacuum to the speed of light in the medium. So we have N equals to C over V, where C is the speed of light in vacuum, 3.0 times 10 to power 8 meters per second. And V is the speed of light in the medium, and we know that light travels the fastest in vacuum, so this value will be less than 3.0 times 10 to the power 8 meters per second. So when you have a bigger value here divided by a smaller value, you know that N is always greater than 1. Also, take note that your refractive index is a ratio, so it does not have any units. Okay, this table here gives us the speed of light in different optical media, as well as the refractive index in each of the medium. Okay, we can calculate the refractive index n using the formula we learned earlier, n equals to C over V. Example, if you want to calculate the refractive index of glass, you substitute C, which is the speed of light in vacuum, 3.0 times 10 to the power 8, divide by the speed of light in glass, which is 2.00 times 10 to the power 8. You're going to get 1.5, which is given here. Okay, and you know that speed of light in air is very similar to that in vacuum. So when you do the calculation, you find that the refractive index is very close to 1. For all the others, they are greater than 1 as mentioned earlier. Okay, the next part, it says the higher the value of the refractive index, the slower the light travels in the medium, and the smaller the angle of refraction R, because the more the light bends towards the normal. Let's take an example. You see this diamond has the highest refractive index amongst these. Its speed of light is the slowest. So for example, when my light ray enters from air into water, okay, it will bend towards the normal and give you this angle of refraction R. But when the light ray travels from air into diamond, it will slow down even more, so the light ray will bend even more towards the normal, and this angle of refraction R now is much smaller. So this is what this is talking about. Okay, this table gives a little summary of what we have covered so far. So for an optical medium which has a high optical density, it will also have a high refractive index. So when light enters this particular medium, the speed of light will decrease in this medium. Okay, and when the speed of light decreases, the light ray will bend towards the normal. So when the light ray bends towards the normal, the angle of refraction will become smaller. For example, from air to glass, the light slows down, the light ray bends towards the normal. Okay, whereas if I have a low optical density, I have low refractive index. So when light enter this medium, the speed of light will actually increase, and the light ray will bend away from the normal, giving you a larger angle of refraction. So like from water, you're entering air which is of a lower optical density. The light ray will bend away from the normal and give you a bigger angle R here. Slide 14. This is a section to test yourself. Which material in the diagram below has a higher refractive index? Explain your answer. The hint, you need to look at the angle of refraction. So you will need to draw in your normal first. Okay. Attempt the question after slide 15, and then you complete the quick check one together before you move on to slide 16. Slide 15, they're asking if whether reflection and refraction can occur simultaneously. Answer is yes, which we covered earlier on in the front part of the topic. Okay, so light is both reflected and refracted at the air and glass interface. So here you have your air entering the glass surface. There is refraction taking place. At the same time, there is also a weakly reflected ray. Why? Okay, the amount of light reflected is usually smaller than the amount of light refracted. So this ray is a weakly reflected ray. Now I have 4 questions regarding angle X and angle Y in the quiz quick check 1. Go and attempt the questions first before you go on to slide 16.